So here you go, boys. Big Clive style angle on the camera. So I got myself a new wee toy from Amazon. $30 Canadian. So what's that? $20 American and 13 pounds, British pounds or something. Anyway, what is it? It's a digital thermometer. As handy as these are, there's a limitation on them, of course, that they're really only good for surface temperatures. If you want to measure air temperature, they're kind of useless, right? So I bought myself this, as I said, via Amazon. Steel at $30 Canadian. Good wee rig. Professional, of course, right? None of your rubbish. You might notice, you might have seen some other, if you're interested in this kind of stuff, you might have seen this, and it looks awesome on camera, right? Believe me, it doesn't belie the cheapness of how poor quality the plastic is. This is not a rubber surround, it's just an inlay in the plastic, but it looks good, right? And it actually feels good, to be fair. There's nothing wrong with it feel. And so there's not a whole lot to tell you about this, boys. Big Clive would do a better job on the lighting, eh? What is there to tell you? It's a dual temperature thermometer. Digital display, of course. Here's the type of thermocouples it can actually use and its ranges. Now that's, I guess, that's the units range. That is not the effective range of these probes because they're extremely cheap, as you can imagine. In fact, I can't imagine them any cheaper. But they're pretty good. I'm pretty happy with them. They're going to do exactly what I hope we're going to do, and that is just take some surface temperatures. I like tinkering with some stuff, and there is a polarity on these boys that you've got to get right. As you can imagine, thermocouple is a junction of, let me not embarrass myself. There is in a thermocoupler, there's two dissimilar metals, of course, and the Seebeck effect generates a small current between the two if you impose some heat on the end of the probe. So two different temperatures, the T1 and the T2. It tells you what type you're actually selected on, and you can have a min, max, an average. Let me turn the light off here. There is a backlight. The manual says you can go between Fahrenheit and Celsius. Yeah, I know some guys prefer one unit over the other, obviously, depending on what part of the world you're in. The manual says the backlight will stay lit for 30 seconds. Well, that's a really quick 30 seconds, eh? But so what? Who cares, right? Boy, swamped it, as Big Clive would say. I swamped the camera. If you don't know who Big Clive is, go check him out. A mad Scotsman. I think he lives in the Isle of Man, actually, but he's a clever guy and interesting character. Yeah, so you can get the two temperatures. You can swap the T1 and T2 top and bottom, and you can actually get the differential as well, right? So you obviously the top line there showing you the differential between the two temperatures. So that's about it. I'm not going to labor the point on this, boys, because I don't think it's good enough to publish a video just based on this, because there's plenty of better reviews than this, than just my introduction to this product. I don't even know the product number, or of course it's cheap Chinese. Just basically Google or look on Amazon for dual digital thermometer, and you'll find it. As I said, it's about $30 Canadian. But I have a use for this. I want to show you, yes, some more air conditioning topics for discussion. I know some of you are probably not interested, but in case you never noticed, my channel is strictly about my interests, and if anybody else happens to be interested in, so much the better. But I won't not publish a video because I think people are going to get bored of it. That's neither here nor there to me. It doesn't bore me. Right. So out to the car, and I'll show you a scenario that could transpire on your vehicle. Air conditioning will be rendered essentially inoperative, but there's a pretty simple diagnostic that you can perform in order to narrow down exactly what it is. Okay, so I'm in my car here, boys, clearly. So one of the probes, T1, the top line, is actually the duct temperature, and I've just got the other probe just hanging here to give me a cabin temperature, and yes, it is smoking hot today. 35 degrees outside temperature. That's hot for this part of the planet. Try and keep my fingers out of the frame. Okay, so here's the scenario. I'm going to start the car. I'm going to turn my air conditioning on. Turn my air conditioning on. Turn the temp down. Watch the duct temperature. So that looks good, right? You can see the duct temperature is dropping. Clearly we're getting some cooling happening here. So that looks good. I'll just turn the fan down a wee bit here, boys, so you can actually hear me a bit better. Yeah. So I won't say anything more. I'll just let the film roll here for a minute, and I'll speed it up because you're going to see there is going to be a change in scenario soon enough. And there's nothing wrong with my car. I've rigged it to simulate this particular fault scenario. So you'll see what's going to transpire shortly. Okay, so I've changed my location here, boys, because well, I've got to pick up my son for work. You can see the time shift there, and I have the fan actually on low. You can see the discharge temperature for the ductwork is actually quite cool, right? So I'm going to ramp up the fan speed, so I'm going to have to speak up, but watch what happens as I ramp up the fan speed. So the duct temperature is climbing, and the higher my fan speed, the higher the duct temperature is climbing. That's maximum fan speed. So keep an eye on the duct temperature. You'll notice I'm in the shade now, and the outside temperature is actually 27 degrees. It's dropped significantly from when I was actually in the driveway. So it's a couple of minutes later, boys. You can see my cabin temperature, T2 there, really hasn't shifted at all from our start point. It's still at 31 degrees in the cabin. The duct temperature is now up to 20 degrees. My fan is in fact on full blast. The AC is at maximum cool. And basically the longer we sit here, the higher the duct discharge temperature actually goes. Still 27 degrees outside. And now we're down to, well, let's use the function. What's the differential temperature? 10 degrees differential temperature between cabin and discharge temperature, duct discharge temperature, and falling, right? So basically the longer we run, the less and less cooling we actually have. How come? What's the issue here? Well, there's a simple way to actually check this situation. Okay, so we have our chauffeur on board, so we can continue with our so 19 degrees and a cabin temperature of 35. That's not good enough. The differential is typically between the outside temperature and your duct discharge. Ideally is about 20 degrees Celsius. By the way, let me toggle for our non-Celsius speakers. There's the Fahrenheit difference, boys. Okay, so let's roll, Stevie. So keep an eye on the duct discharge temperature here, boys, just as we start rolling. Again, I've got my son driving, so we're good to go. Yes, he does in fact work it. maybe big box shops, shall we say. And right on cue, of course, the sun is right in our view, so we can't see nothing. Okay, so as we're moving, sorry about the shaky camera work here, boys, I'm doing my best. As we're moving, you can see our duct discharge temperature is actually going down. So we're just in and about the streets here. You can see our speed is no more than just in-town speeds. And now we have reasonable cooling again. In fact, I can feel it. It's quite a bit different. Okay, so as long as the car is in motion, we have, in fact, the air conditioning seems to be operating quite normally. You can see we're heading towards that. There's a 20-degree differential. So that's pretty normal operation so long as the car is in motion. Okay, so just watch the temperatures here, boys, just as we're pulling into my driveway. Okay, so this would be a typical red light scenario, minus the intersection of the lights. We're just, point being, we've gone from being in motion to stationary now. And you can see the duct temperature is climbing at a significant rate. So this scenario is a dead giveaway that your condenser fan is not running. So here's a quick look at the component location drawing in the manual here, boys. Condenser fans don't tend to run if you have the relay in your pocket, right? As I said, I've rigged this to simulate this scenario. So here's the condenser fan, obviously in front of the condenser coil at the front of the car itself. Again, without reviewing the entire AC circuit, boys, appreciate that the condenser coil is the component in the AC system that dumps the heat energy from the cabin, basically, right? The evaporator absorbs that heat energy into the refrigerant, and the compressor circulates it towards the condenser. The condenser ultimately, the gas turns from obviously vapor to a liquid state, i.e. Meaning that's what the whole condenser is actually for. And in the process of condensing, the refrigerant actually dumps the heat energy to the outside. So without that airflow over the condenser, clearly is not going to operate. It's not going to function efficiently, right? The whole point of an exchanger, this is a refrigerant to air exchanger. You need that airflow, right? So where does the airflow come from? Well, as we've seen when the system was functioning normally, so long as the car was in motion, clearly there's ram air across the front end of the car, and that provides the necessary cooling, or at least adequate cooling. As soon as the car is operated in very, very low speed with a high demand, there's not enough air exchange over the, not enough heat exchange over the coil, because the airflow is simply not there, because the electric fan is not there to assist. So that's a dead giveaway that you have an issue with your condenser fan if the duct temperature starts to raise when the car is stationary. Dead giveaway. I'm not only showing you this because it's a scenario I've thought of, boys. It's a scenario I've ran up against a couple of times in the past with in fact, a couple of Suzuki products. A Chevy Tracker, which is essentially a Vitara. I had that happen twice on two of my previous vehicles. Just a quick look at the schematic here, boys. So, a couple of things that can transpire so that your condenser fan won't actually run. You can see the circuit here, boys. We basically have a 12-volt supply from the distribution network, and it comes to the relay here, IM26. There's a relay that is powered directly from the, as I said, the power distribution system, and the ground is applied via the engine control module, depending on the scenario that's presenting itself, i.e. the air conditioning is operating and the temp and the cooling is actually required, right? So here's the condenser fan itself. So a couple of things that can actually happen. Obviously, you can have an issue with the supply voltage. Maybe potentially fuse is actually gone. You have a wiring issue, a bad ground. More likely, you have an issue with the fan itself, where the bearing is actually gone and the fan is actually starting to seize and actually has caused the fuse to blow. That's possible. The condenser fan is behind the condenser coil in the SX4. However, in some other vehicles, and this is pretty typical system, of course, boys, in some other vehicles, the condenser fan is located in front. In Canada, this actually becomes an issue because people tend to ram their vehicles through snowdrifts. And guess what? They end up ramming their condenser fan straight into the coil itself. Of course, it binds the fan, and then you have problems. Typically, it'll pop the fuse, but you've mechanically jammed the fan, or of course, the bearing can actually go as well. So, anyway, we'll leave it at that, boys. That was just a quick look at the wee Mickey Mouse tool, and I thought it would make some sense to actually see it in action, because it's quite effective at what it actually does, right? And I was pretty happy with this. I thought it functioned quite well in that little demonstration. So we'll leave it at that, boys. It's probably dragged it far too long. But the tool, we bet a two for tonight, the tool itself, and a scenario that can transpire where you're with your air conditioning. So one thing I wanted to mention before to conclude this, I made a mental note to myself to make this point. Yeah, so in the event you run into an air conditioning issue, boys, don't automatically think, well, I don't know nothing about air conditioning, I don't have the tooling, I'll pass that on to somebody else, I'll give that a pass. Just take a look. Maybe it's something obvious, if a scenario like this, you don't need any specialized tooling. You might get lucky and you might be able to deal with it. So, yeah, that's it for tonight, boys. I hope that made some sense. Right, cheers. Mention it? Yeah, okay, alright, I'll mention it. Okay, these are extremely poor quality little probes, boys. I knew that fine well when I purchased this. Now keep in mind, notice how I put a wee dot so I can orient it. I don't have to struggle with which way the pin configuration goes. These are kind of a standard pin configuration. These are chrome-L and alum-L differential metals in the probe itself. Not that that matters, but these are, being a standard configuration, I'm going to buy some better quality probes, and I think I'll be able to put this to good use in the time to come. $30 Canadian, how do you go wrong? Right, that's it, boys. Cheers.